I've already written down my working out for this question just to try and make the video a little bit shorter. I'll just talk you through it. We had a graph of a parachutist jumping out of a plane. Part A said we needed to work out the acceleration of the parachutist when t was 8 seconds. So I went to 8 seconds on the time axis here, and I went up to the graph and then I drew a tangent at that point, because I'm looking to work out the rate of change of the velocity at that point to work out the acceleration. So I drew a tangent with my ruler, so a line just touching the curve at that point, and then I picked two coordinates off that I could read off easily. I picked this coordinate here, which is the coordinate 10, 54, and I picked this coordinate here, which is the coordinate 2, 42. And then to work out the gradient of this tangent, I did the change in the y coordinate, so 54 take away 42, which is 12, divided by the change in the x coordinates, which is 10 take away 2, which is 8, and 12 divided by 8 is 1.5. So that was part A of the question. Part B said to work out an estimate for the distance the parachutist falls in the first 6 seconds. So the distance is the area underneath a velocity time graph. So I wanted the area between 0 and 6 seconds. So I split it up into 3 equal strips. The first one here is a triangle, the second one is a trapezium, and the third one is a trapezium. To work out the area of this triangle, I did a half base times height, so half 2 times 20, which is 20. For a trapezium, remember the formula for the area of the trapezium is half of A plus B times by height. So half of 20 plus 35 times by 2, which gave 55. And then similarly, half of 35 plus 46 multiplied by 2, which is 81. Add those together, and the total distance travelled is 156 metres in the first 6 seconds.